Hi, sixth graders, it's Miss Swain. So today we're going to look at identifying equivalent expressions. So on the screen right now, you see three terms. A term is anything that's combined together. So in this case, a term is the variable c, or the term is the number 3, or the term is 3c. When we're asked to find like terms, what we're really being asked is to find terms that have the same variables. So in this case, we have the term c and the other term 3c, and both of these have the exact same variables. So our like terms are going to be c and 3c. Let's look at our next example of why we might need this. What happens if I'm given the expression s plus r plus s? How can we simplify that so that we don't have quite as many terms to look at? Well, if we start by looking at like terms, we would see that there's an s at this side and an s at the end. So when we combine those two terms together, we can actually see that we can add them together, and instead of having two single s's, we can combine them to have two s. And then we only have the single r left. So can you see that right now the expression 2s plus r is equivalent to s plus r plus s? This is useful when we want to combine terms together and make a simpler expression, but one that's still equivalent. Let's look at another example on how we might use something similar to combining like terms. Now let's look at how we might use expanded form and how we might make that into factored form. Here's our next example. In this example, we have the term 6s and the term 18. So the idea is, how can we take this expanded form and create this idea of factored form? So going back and looking at our two terms, again, that's our 6s and our 18, we begin to look for our GCF. So I'm going to look at my GCF, I'm going to look at 6s, and then I'm going to look at 18. Well, if you look at 6s, this is really the same as 6 times s, and 18 is the same as 6 times 3. Can you see that our greatest common factor in this case is really the 6 here and the 6 here? So now that I know that my greatest common factor is really 6, to the outside of my parentheses, I'm going to put the 6. Then I'm going to add my parentheses. This is indicating that I'm really going to multiply something, and in this case, I'm going to multiply this entire quantity. And I'm going to multiply that by everything that's left over. So I still have this s that's out here that I didn't use, and I still have this 3 out here. So it's going to become s plus 3. So again, the 6 right here is my GCF, so this was where my GCF came from, and then all of this other stuff is what was left to multiply to get my original terms. So 6 times s gives me my 6s, and my 6 times 3 would give me my 18. So remember, this is again my expanded form, and this would be my factored form. So they're opposites of each other. So now let's look at an example. If I'm given factored form, how do I take that into expanded form? In this example, I have 2 times the quantity. So the quantity means everything inside the parentheses. And my quantity here is z plus 4. So when we say that expression, it is 2 times the quantity of z plus 4. So remember that when we look at parentheses, there is always an operation between the number on the outside of the parentheses and the actual quantity. So in this case, this is really saying 2 times this z plus 4. So I'm going to use that distributive property. So the distributive property says I'm going to take this 2, and I have to multiply it by every term that's inside the parentheses. So at first I'm going to take the 2 and multiply it by the z. So I have 2 times z, and I'm going to keep the sign that we were given. So it's going to be plus, and then I'm going to take this 2 and multiply it by this 4. So the next one's going to be 2 times 4. And now we're going to reduce. So 2 times z gives me 2z. Keep my addition sign, and then I'm going to multiply that 2 times that 4, which is 8. So now I have successfully gone from that factored form all the way down to that expanded form. Notice that they're opposites. So we could use the same thing that we did in the last example and take our expanded form, which remember is this one at the bottom, this one down here. And we can factor that, and if we did that, we would get this solution at the top. So it's kind of like addition and subtraction, that they undo each other. Factored and expanded form also undo each other. Now let's do some examples that you try them on your own. Here's your first practice problem. You're being asked to choose the like terms. Again, your terms are AB, 2AB, 3B, and 2A. Try it now. So pause the video, and when you're done, hit play. Did you get that your like terms were AB and 2AB? If you did, you can move on to the next practice problem. If you didn't, stay with me while I explain why the solution should have been AB and 2AB as like terms. So remember that we said like terms have the same variables. So in this case, we have two variables that are being multiplied together. That's A times B is what gives us that AB. In the next term, we have 2 times A times B, and that's what's giving us the 2AB. So here we have two variables, AB, and in the second term we have two variables as well. That's 2AB. Now our next term is 3B. We're getting 3B because we have 3 as the coefficient and a single variable B. Notice that that B appears in the first two terms, but it's missing the variable A. So, unfortunately, it doesn't qualify as being a like term with AB and 2AB. If we look at our last term, that's the term 2A. So this is 2 times A, and while the A matches the first two terms, it's missing B. So again, it doesn't qualify as a like term. So our two like terms in this case are just AB and 2AB. Now let's look at the next practice problem. So here's our next problem. We're being asked to simplify the expression 5x plus 2x minus 5y. Use your notes from before and see if you can simplify the expression by pausing the video and trying the problem on your own. Did you get that the solution is 7x minus 5y? If you did, you can move on to the next practice problem now. If you didn't, stay with me while I explain why our solution should have been 7x minus 5y. So if we look at our terms at this point in time, we have the term 5x plus 2x, and then we're subtracting from that 5y. Do you see that 5x and 2x are like terms? Because they're like terms, in this case I can add them together. So I have my 5x and I'm adding to that 2 more x's. So that's a total of 7 x's. Now, I still have to keep in mind that I have this last term, this minus 5y, and it doesn't just disappear. We have to carry it with our solution. So we're going to add that to the end of our solution. So we're going to add in that minus 5y. So we haven't forgotten it. It's still sitting there. We're just moving it to the end. It didn't have any matching like terms, so we didn't have to do any math with it. We're just continuing to carry it to the very end. So this is why our solution was really 7x minus 5y. Let's look at our next example. So our next example asks us to factor in the expression 3u minus 15. Pause the video now while you try and come up with a solution of the factored form of 3u minus 15. Did you get the solution 3 times the quantity of u minus 5? If you did, you may move on to the last practice problem. If you didn't, stick with me while I explain why the solution is 3 times the quantity of u minus 5. So remember we said earlier that we have to take our terms and we have to find the GCF. So we're going back and we're going to look at what is the GCF, and I'm looking at the term 3u and I'm looking at the term 15. Do you see that 3u is really 3 times u, and 15 is the same as 3 times 5? In this case, our GCF is going to be the 3, and everything else is our quantity. So we're going to take our 3 and add our 3 as part of that GCF on the outside of our parentheses. We're going to draw our parentheses, and we're going to take everything else that we didn't use, and we're going to move it so that it's inside the parentheses. So here's where our u is going to be. So this u is going to get dropped in right here. And I'm going to borrow the sign from the original problem. So here's the sign of the original problem. I'm going to put that in my parentheses as well. And then I'm going to put in the remaining term that I didn't use for 15. In that case, it's 5. So here's that 5, and I'm going to drop it in the last piece of my parentheses. And then I close off my parentheses. So this is why my solution is 3 times the quantity of u minus 5. Let's try the last practice problem. So my last practice problem says to expand the expression 3 times the quantity of 5 plus w. Try this problem on your own, and when you're done, hit play so you can check your solution. Did you get the solution 15 plus 3w? If you got the solution 15 plus 3w, give yourself a hand and you may begin your practice quiz. If you didn't get the solution 15 plus 3w, continue watching while I explain why this is our solution 15 plus 3w as the expanded form of 3 times the quantity of s plus, or of 5 plus w, excuse me. So here's what we're looking at. So remember that when we expand, we're using that distributive property. So the very first thing we're going to do is we're going to take this number on the outside, and we're looking to see what the numbers are inside, and we're going to multiply them together. So what I have here is 3 times 5. I'm going to borrow the sign in the middle because it stays the same at this point. So my sign is going to be just the same, and then I'm going to take that 3 again, and I'm going to multiply it by that w. So I get my 3 times w. 3 times 5 gives me 15. I'm bringing down my sign. It doesn't change. and then I'm looking at 3 times w, so I get the 3w in its place. So that's why our solution is 15 plus 3w. Remember, you can go back and re-watch the video if you're still a little confused on any of the aspects. Thanks, 6th graders, for letting me drop by your classroom today. We'll see you soon. Bye.